Okay, Algebra 1, this is our last unit. It's a mini unit on graphing. Okay, so it should be fairly straightforward. What we're going to do, we're going to graph these 5 functions. Now, some of these you're already familiar with. X squared should be pretty easy. If I'm graphing this function by plotting points, if I'm graphing f of x equal x squared, then all I need to do is take this number and square it. So you get a 4, a 1, a 0, a 1, and a 4. So 0, 0, and you already know this one, over 1, up 1, over 2, up 4. So these are 1, 2, 3, 4, 5 exact points, and you know the graph of this guy looks just like this. It's a parabola. Okay? Now let's look at f of x equal the square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So it's going to go through 0, 0, 1, 1, 4, 2, 9, 3. So here's the graph of this guy. Now notice I don't have any negative numbers here because the square root of -1 is not a real number. So this one looks different. It only exists for positive numbers. And what we want to do is get to a pattern. So this thing starts at 0, 0. I go over 1, up 1, because the square root of 1 is 1. I go over 4, up 2, because the square root of 4 is 2. I go over 9, up 3, because the square root of 9 is 3. Next one is the absolute value of x. Absolute value just takes a number and makes it positive. So the absolute value of -2 is 2, 1, 0, 1, and 2. So again, it goes through 0, 0. It goes through 1, 1, -1, 1. So this is similar to a parabola, but then it starts to break off. It goes through 2, 2, and -2, 2. So what this guy does is sort of like 2 straight rays emanating from there. So this is the absolute value of x. So it looks like I started at 0. I went over 1, up 1, because the square root of 1, the absolute value of 1 is 1. Over 2, up 2, the absolute value of 2 is 2. Left 1, up 1, the absolute value of -1 is 1. Left 2, up 2, absolute value of -2 was 2. So this one sort of looks like a V. Okay. F of x equal x cubed. So -2 times -2 times -2 is -8, -1 cubed, 0 cubed, 1 cubed, and 2 cubed. So this one again goes through 0, 0, like all of them. It goes to the right 1 and up 1, because you cube 1 and you get 1. Cube 2 and you get 8. Cube a -1 and you get -1. Cube a -2 and you get -8. So this one sort of looks like this. This is x cubed. So in this one, the pattern was sort of starting 0, over 1, up 1, because you cube 1 and get 1. Left 1 and down 1, because you cube -1, and you get -1. And then x to the 1/3, or the cube root of x. The cube root of -8 is -2. Cube root of -1, cube root of 0, cube root of 1, cube root of 8. So 0, 0, 1, 1, what is it, 2, 8, excuse me, 8, 2. And then -1, 1, -8, -2. So this one sort of looks like this. This is x to the 1/3, or the cube root of x. Okay. So again, we've graphed all of the functions now. So this one, went through the origin and it looks like a bowl. It's the parabola. The square root of x is the one that looked like this. The absolute value is the one that looked like the V. X cubed looked like this. And then x to the 1/3 looked like this. Okay. So 1, 2, 3, 4, 5 of these functions. Now, what will be helpful, just like we did with the parabola, if you can know the pattern of what happens rather than plotting points. So x squared, remember we always said it started at 0. Over 1 up 1 because you square 1 and get 1. Over 2 up 4. Over 1 up 1, you square -1 and get 1. Square -2 and you also get 4. So this one we know how to do by just memorizing its pattern. Okay, so there's the pattern. Now, what would it look like if I graphed this same thing with a vertex at 5, -4? 5, -4 is here. So the pattern would be what? Over 1 up 1, over 2 up 4. So this is what it would look like if I graphed an x squared, but with a vertex of 5, -4. So that's a lot better than having to plot and plug in points for that guy. So let's look at this one. So focusing on the pattern. So again, we've already done this one many times. X squared. I think you've got this one down. Looks like this. Now the absolute value of x. Start at the origin. Over 1. What's the absolute value of 1? 1. Absolute value of 2? 2. Absolute value of 3? 3. Absolute value of -1? 1. So you see the pattern here. It just makes a V. Okay. Now notice it has the same over 1 up 1, over 1 up 1. Over 1 up 1, over 1 up 1, but the shape is a little bit different. The first one is the parabola like a bowl. The second one, is more like a V. If I look at x cubed, starts at 0. So over 1 up 1, 1 cubed is 1. 2 cubed is 8. Right there. -1 cubed, -1, -2 cubed, -8. So that lets us know what this graph is doing. The cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of -1, cube root of -8 is -2. So it's very similar to x cubed, but this guy sort of is a vertical. This guy is more of a horizontal. Okay. And then the last one is the absolute value of x. So, square root of x. The square root of 0 is 0. Go over 1 up 1. The square root of 1 is 1. My next perfect square is 4. The square root of 4 is 2. The square root of 9 is 3. So that's how I see the square root guy. Now, you can use hand signals, dance moves, whatever you want. This is what x squared looks like. Hold your hands up like you're signaling touchdown. So x squared, is the parabola. Our pattern for graphing that guy was here. Over 1 up 1, over 1 up 1, and it is a bowl shaped. Absolute value of x just looks like a V. The pattern for that one, we start at the origin. Over 1 up 1, over 1 up 1. So the same pattern, but it has a different shape. Okay, it looks like a V. The square root of x, okay, it just goes off to one side. Starts at the origin. Over 1 up 1 because the square root of 1 is 1. Over 4 up 2 because the square root of 4 is 2. Then x cubed. This one, if you see the way it looks, is one arm up, one arm down. The pattern here starts at 0, over 1 up 1, because 1 cubed is 1. Over 1 down 1, because -1 cubed is -1. X to the 1/3 has the same pattern. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of -1 is -1. But this one has more of a horizontal graph. Okay. So if you can know what these graphs look like, then it's much easier to plot them. So let's graph x squared, but with a vertex at 3, 4. So it means graph my x squared over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. So there's the pattern for x squared with a vertex at 3, 4. Absolute value of x. The vertex moves down 4 and the graph is upside down. So it's going to move down 4. Now my pattern would normally be over 1 up 1. It's going to be over 1 down 1, over 1 down 1, over 2 down 2, over 2 down 2. So this is an upside down V. And so all you keep in mind that normally the graph would have looked like this, then you know what it looks like when it's upside down. The graph of x cubed, it goes left 6 and up 4. So x cubed, over 1, up 1, because you cube 1 and get 1. Over 1 and down 1, you cube -1 and you get -1. Over 2, it goes up 8. 1, 2, 3, 4, 5, 6, 7, 8. Over 2, 1, 2, 3, 4, 5, 6, 7, 8, right there. So you see this going on with this graph. If I look at the next one, the cube root of x, starts, so I want to move the graph up 4 and upside down. Okay. So keep in mind the pattern for the cube root. Normally I would go over 1, up 1, over 1, down 1. This is the one that's going to be horizontal. So if it's upside down, instead of going over 1, up 1, I go over 1, down 1, left 1, up 1. And this is the one that looks horizontal, so it looks like this. The square root of x, move the graph left 4 and down 6, and the graph is upside down. So keep in mind, normally I would go over 1, up 1, over 4, up 2. That's my square root of x. So now instead of going over 1, up 1, I'll go over 1, down 1, over 4, down 2. This guy is upside down. Okay. So again, if you know the pattern, it just makes it easier to graph these guys. And that leads you up into the homework for this section.